and I'm about to break.
Oh my God.
I was gonna do the little, I can't do
Yeah,
it.
no.
Not Linkin Park or Chester. Is that Chester? Yeah.
Hello, viewer/listener. Welcome back to Break. We did miss last week, so but we're back. We're gonna keep this thing going. Sometimes we stumble, but we got to get back up, going. This is Break for episode 60, which is exciting. I am slightly sad that the numbers of Break are now off by like 31 instead of 30. It's very nice to just have them be like so perfectly apart. We'll just have to do an extra break somewhere to get everything back on track. But yeah, this is for Fallthrough episode 60. And yeah, Matt, I feel like you have lots of opinions that you want to swear about. So now you can swear. So
I'm trying not to swear as much. I really am.
I think you only
said
damn twice last episode on the episode. So
yeah, that wasn't so bad. I didn't say any of the hard words. No, I just I wanted to. I did say my piece about the Slack stuff of like feeling like the conversations are very much just you're holding it wrong. So I did get to already say that in the episodes. That was good. No, I was just thinking more about that database SQL design, right? Like, it's weird to me. Like, I don't like when packages are imported and then like not shown in the file. Like I can't, if I import package foo, I can't, and if I control F for foo and it's not in the file, I can't stand that. There needs to be a link from the import to some usage in the file for me. Like I like to see that. And the database SQL design specifically breaks that for me, where it's like libpq is imported, but you can't find like any libpq references in the file at all. Like you just can't find any because it's not meant for that. No, I know, but like I don't like it because I don't know what it means, and like it's very easy to just not know that that's load bearing in a way, right? And same thing with the like when you call SQL.open and you pass a driver name of Postgres.
Well,
that's also decoupled. That's also decoupled from the import, because when you import libpq, it runs an init function which registers Postgres as a driver for SQL. But even that is using a string, like a raw string, like a literal, and then you're meant to put a literal in your SQL open, and there's nothing that ties them together. Right. So if you typo Postgres, it won't load. Like I would rather see a design where it's like SQL.open, pq.driver name. Like a constant, right? So it ties the import together, and you still get that sort of init function side effect that you wanted. But I know that would be a little bit more of a pain to use. I get it, but at least it'll tie things together a little bit and really show like, hey, this is how the drivers are linked. But that's just my opinion. I don't know if it's a better design or not. I just, just was thinking a little bit about it while we were chatting.
Yeah, because part of me is like, a nice clever design would be to pass like the driver type to it.
Yeah,
but because that's the kind of some of the stuff that happens in PHP, where you can actually like pass a class, the class itself into something to be like, this is the type that I want you to do something with or whatever. That's cool. Yeah, the whole strings idea, I guess it like walks an interesting line of like, okay, well then in your test you can register a fake driver for that, so then all your code stays the same, and you have to do something special for testing. But then it's also like, why are you not testing your driver if you're instantiating the driver? Like that's a weird boundary to have right there. So it's like I get the original thinking behind it, but I think there's a lot of reasons why that's not a good design in hindsight. And it's like we should probably be structuring our code differently, and we should be recommending people structure their code differently. Because it's like why are you like why stub out the driver itself? Because now you just have to write a whole bunch of SQL. Like I don't know. Using SQL mock was one of the worst experiences I've ever had. Like I hated having to maintain that code because you make any changes to your queries.
I didn't care for it either.
You what?
I didn't care for that code either.
It spewed so much code that you had to maintain. You changed a single query somewhere, and all your tests are breaking because the mocks aren't getting the query they expect. So you got to update all the mocks, and then you have to figure out how to actually do that. It was, once again, a good idea, but just terribly implemented. And it's like, we probably should have, and like what I eventually started doing is I'm just not going to test that layer unless I'm going to run it against an actual database. Like I'll run against a real database. I'll spend the time putting data into the database, putting the text features into the database instead of pasting all of the SQL queries I expect you to see to give you fake data back. Like, no, let me just actually use a real database and then abstract, decouple my data layer from the SQL layer. Like the SQL layer just implements some data layer, and I can test the SQL layer on its own against a real database and test the rest of the application against a fake data layer, and there we go. And so it's like the design of the SQL package is like, it makes sense for a very specific certain way of doing things that I just don't think are a good way of doing things in the modern day. So that one. And also with the way modules work, having modules with side effects is just like a bad idea all around. Because when you V2 it, you have a whole bunch of questions that you are not responsible for answering that are just not fun to answer. So.
Yeah, I mean, it's oh man, yeah. I remember I implemented like an in-memory database mock for myself to do tests, and I was like, this kind of sucks, because then you have like, you're using like a list or sorry, you're using a slice or a map has the implementation under the hood, and like both of those have differences than how a database works, and like and then I did SQL mock and I was like, this feels weird. So I was like, I'm just going to test against a real database and then mock out like what I need to test specific error cases or whatever. And it's rough. At some point it's like, what are you testing? You have to really ask the question of what do you want to test? And if you want to test that Postgres, successfully serves a query, well, they're already testing that. Like Postgres is already dealing with that stuff. You should test how your app behaves when Postgres doesn't respond with the right response or something. You know what I mean? Yeah, testing's hard. The more I talk about it with people, and the more I talk about it and try like with myself and whatever, it's difficult to really nail down what you want to test, because you can get really quickly into a position where you are testing a bunch of useless stuff and it feels good, right? It's like, I got the mock and it's like, yeah, but you're just testing that like the sky's blue. That's what you're testing again and again and again. Like this is not actually giving you any new assertions or guarantees. But yeah, maybe the SQL package would have been designed differently had it been designed today with like generics and some other features to the language. Maybe it would have been designed differently. I'm not sure. And this is, to be clear, I don't hate the design. I'm not sitting here saying like this design sucks and it's the worst. It's just, for me, the disconnect of the package importing, having a magical side effect, and not being used anywhere in the file. Really, it's a disconnect, and I don't like that personally.
Yeah. No, I agree. I think that like global side effect packages are just, or singleton packages, I just think they're a bad idea. Like I feel like a lot of what we've seen in recent years about how to like structure good applications, it's like have as few side effects as you can, and like keep the side effects you do have constrained, right? If you can constrain them to just like your type that you're working with, I think that's fine, because you can instantiate multiple versions of that type, right? But I think anything that has lots of global side effects is just like a not great way of writing Go code. And I think that's a thing the community found out pretty early. I think we all moved away from the designs that had global ramifications. Like I think a lot of us started moving toward like, okay, no, you have a type and just write the glue code. Just write the code that actually puts the thing together instead of just having it automatically happen. Because in a way, it is kind of magical, right? It's very weird, like not Go like thing to have magic like that.
Yeah, I agree. And it's like not like I want to like ban the use of init anywhere, because there's times where maybe it is going to work for you. But when like, what's the goal, right? I am an application developer, and I want my application to talk to Postgres database. That's my goal, right? I want to open a connection to a Postgres database. And like to kind of have some magic there feels weird,
right?
Like I know that the database I want to target is Postgres, so like let me get the driver, let me put it in, let me specifically call that. I don't need it to just magically. I don't need the driver to just magically be loaded. Like I want to see like I am calling. I want the driver and I'm passing it here. Like I want to see that,
right?
But maybe people don't, maybe I'll get a comment somewhere in some message somewhere saying like you're holding it wrong. Maybe I am.
I think the SQL package specifically is one where I've not seen people push back and say this is a great design. I think you're wrong for thinking it shouldn't be this way. I think most of us are like, this is the design war, and like we can't get away from it because of the Go 1 compatibility promise. So
yeah, but we can have a SQL v2 package.
We could have a SQL v2 package. I don't think anybody cares enough to work on that, but we could. I think,
and I don't blame them for not wanting to work on that, because I wouldn't even want to work on that. Like
I think like in the current era of databases, like there's too many different types of databases now that don't use regular SQL. And I think people are just like, I'll just import the driver directly. I think that's what a lot of databases are like. Here's a driver, you just use it. You don't need to have a wrapper library around it in the standard library. So I think it's like it's definitely not big enough problem where people want to, solve it. Like it's not like the JSON problem where it's like, no, we really do need to fix this in the standard library, because like trying to convince people when there's a standard library thing that they should actually be using this third-party library because the performance of the standard library one is like garbage for a lot of use cases, is like that's a hard sell. Just put the right thing in the standard library, please. And it's really hard to argue that JSON should not be in a programming language's standard library. It absolutely should be and needs to be.
Right. And it's not like the SQL stuff is like wrong or has poor performance. It works. And like we've built abstractions on top of it to like abstract it a little bit more, right? Like to give more features or whatever, or to make the API a little bit nicer to use. And like people have just accepted that, and they use that. And even myself, like I use SQL C a lot when I do Go code, and I love SQL C. I was like, I just write some SQL, you generate some Go code bindings for me or whatever, and I just call into that, and this is great. This works for me. I don't care if you're using PGX or libpq or whatever else other drivers are out there. That's your problem.
Yeah.
And yeah, I feel like that feels good to me. But would it be designed differently if it was today? Probably. Do I care enough to fix it? No. Definitely not.
There's a long list of things that need fixing in Go. I don't think that that is one of the ones that I particularly care about fixing.
Yeah, but no, I think I don't know. I like how packages are a little easy to use in Go, but I think the guidance is, like you said, like we said in the episode, the guidance is really what's missing here. And I'd like to see a little bit more guidance around how to use packages. I like the flexibility of them. I don't know. They feel fine. mapping to like file system paths, like I can go either way on that. But it does make it a little easy to just move the code and then fix imports, especially now with AI. You can just say like, hey, I had foo package over here and I want to like move. I don't want to rename. I'm not talking about the rename case. I'm just talking about the move case. Like I want to restructure where my package is located. That's easy to do, right? Just move the directory somewhere else and like update import paths, because the import path still has the directory layout. But that is not a breaking change, right? Unless the package is external, so people can import. So it's like, I don't mind that. That feels nice. It gives me the maintainer or whatever the freedom to restructure my code as I see fit. It's the rename that hurts a little bit, but it's not impossible. Well, I guess a move is a rename then if your callers are external and relying on the import. Yeah. Is that why import's here? No, I guess not. I mean, I don't know. I guess import just feels like a fake. It feels like TSA, like just security
much
theater.
Like reproducible builds were really a thing about you needing more information that you can verify with the compiler. I think the problem with import paths is that they just do not carry enough information to be as useful as we would like them to be. Right. I think in the fact we can't actually draw a proper circle around where a package, like where a module prefix ends and where the package path begins. I think that's a big problem that needs to get dealt with somehow.
What do you mean? You don't like Venn diagrams? It could be here or here. I do not like that packages and modules have a many-to-many relationship. I just do not like that.
I think I more dislike the fact that this is a not known thing, right? Like an interesting conversation we had in the Fallthrough Go for Slack channel was about like one of our listeners went and he like asked, I think it was Kagi, about the many-to-many relationship. And I also just after having that conversation went and asked like a fresh Claude session, like are packages a many-to-many relationship with modules? And it told me no. And like now that I know how to lay out the conversation, within 3 messages, I was able to get it to be like, oh no, this is absolutely a many-to-many relationship. But it's like something that like that tells me that like the AIs, the LLMs, they absorb what the general consensus of things is. That's what happens when you pile a bunch of internet into them. So like the general consensus is that people don't think of these as many-to-many relationships. They have kind of a star on it, right? They think like, oh, it might be many for a brief period of time as you're releasing versions, which tells me that people think of packages as some sort of like temporal property, which is, or I guess modules is like temporally related, which is really interesting because the entire idea of modules is that they're all meant to coexist at the same time. Right. And it's like, oh, but no, like you might have one version of a module and then like the next version, but you change the package layout. But it's like, I think it shows like the roughness of the thinking around all of this. But I do think like it goes back to like we had to change the import paths to make this all make sense in some way. But if you did that, then all of a sudden the same import path structures would mean different things, which I think would also be confusing to people, right? In the same way that like a seeder, if you change that last number, that's a different network segment, right? Than the same IP address with a different slash whatever at the end. You know what I'm talking about, right? The seeder. Yeah. I don't think that would be confusing if we did have like a slash number at the end of an import path that indicated how many segments of that were the module prefix. Then I think people would get confused because they'd be like, oh, example.com/a/b/c/d/5 is different than example.com/a/b/c/d/2. And be like, I don't understand why that's different. And that would be confusing. And like, we're just stuck in a place where like import paths, like packages cannot be bundled together in any sensible way with the import path information that we currently have. And it's just like, well, we should fix that. And we just haven't. And I think that leads to a lot of confusion for everybody.
Yeah, that is. It is kind of confusing. I don't know. It reminds me of like, you know, Bryan Cantrill's talk. He gave a talk at TalosCon in Europe. And I think the talk is on YouTube now. But he was just kind of, he categorized systems into like this like quadrant. And it was like, you know, engineered systems, created systems, and like, I forget the other 2 sort of categories, but Go in this regard feels less like an engineered system in some regards now, right? Like, because we've kind of just stacked things together on top without really thinking how it affects other things. And that kind of bothers me a little bit.
It's weird because I think if Go,
I'm gonna try to find the quadrants so I can. Like,
it's weird because like with Go, I think we hit a point where, well, I guess if we had kept going with the Unix philosophy, like the Bell Labs, the New Jersey approach of things, we like modules wouldn't exist as it exists today. Right? We would have come up with probably 3 different tools, like one that does retrieving, one that does resolving, and one that does building. Right. So we would have like Go Get and Go. We would have like still have Go Get, but Go Get would probably operate slightly differently. Go Build and like Go Download or not Go Download, but Go Resolve. Right. Like some combination of those 3 things. If we gone with the New Jersey approach, and I think there's maybe a world where we could have gone with the more MIT approach of things, but we like the designers would have had to actually reckon with all of this, right? You would have had to reckon with the reality that there is not a way to have a one-to-many relationship between packages and a project, so that effectively eliminates the ability to have projects. And so you would have to go with a completely different design that doesn't have projects. And quite honestly, if that had been the justification for why we needed to throw out the community work, if it had been like, it is too confusing not being able to pin a package to a specific project, so we need a design that does not have projects in it, I think my entire view of that situation would have changed. Because I think that would have been like a legitimate, like, hey, here's a problem that we have to reckon with that the community work is not reckoning with, so we need to shift it. But I also think that if that had been brought to the community, the community group that was working on this, they might have also changed course. So I think that cuts both ways. But I do think, like, if we want to do the MIT approach of like, we need to have a single solution that solves it for everybody, we would have had to eliminate the idea of projects and been like, package is the universal boundary within Go. Probably also jettisoned internal at the same time and come up with a design that actually fits within those boundaries. And then I think Go could have continued to feel like an engineered system instead of one that just kind of, because, you know, a lot of the stuff that people are stumbling over with modules is because the design has holes in it. Is because the design has like just like truly massive holes in it that need to be dealt with in some real way. And they have just never been dealt with. And so I think that's the thing we all need to figure out how to reckon with. We need to go back to the other method where we have multiple tools and like you can slot in your own tool if you'd like, or we can have one tool that just actually fits with the language and has few, if any, holes. But this middle ground is just, it's very messy. And I do think that, you know, we should fix that. We should find a way to fix that.
Yeah. I pulled up the quadrant here. So like in Bryan's talk, the talk is called The Complexity of Simplicity, and it's on Oxide's YouTube, so you can see it there. And he puts systems into, like, you know, technology systems. He puts them into 4 quadrants. They can be either engineered or emergent. Okay. And they could be either complex or simple. And as you go, like, in, you know, those are the axes. Sorry, those are like the X and Y axes. And then as you go into, like, if you are a simple engineered system, you're revolutionary. If you are a complex engineered system, you're constructed. You're built. If you are an emergent simple, you know, if you're a simple emergent system, you're rebellious, right? Like, because you didn't really engineer it, but you're simple, right. Like you're rebellious. And if you are a complex emergent system, you're accreted, right? Is what he uses here. And I can't say that I know the definition of accreted off the top of my head right now.
Accreted means like
ACCRETED.
Yeah. I know what it. I understand what it means. It's just like defining it is hard. Like,
yeah.
If I look at the definition, grow by accumulation or coalescence. Yeah, I would say like accreted is a good word there. I would also say probably like accreted with a little bit of like internal dissonance, I think, is what he's kind of getting at.
Yeah. Like you just layered on over years and you didn't really compact the layers and like rethink it I think like bit.
That's the thing. Like Go with modules. I mean, Go was already trending in this direction a little bit. I think internal was the first thing that moved it away from Rebellious and into Accreted. Was like Go, but modules definitely shifted it directly into the Accreted quadrant here. Was because like in the beginning Go was rebellious because it was not engineered. It like came about over time. What's the other end of the spectrum? Not engineered, but emergent. It's definitely like a lot of the design of Go I do think was emergent, and it was simple. But I think that you can't take an emergent system and turn it into an engineered system. I don't think that's like a thing that you are able to do. I don't know if you can cross that boundary, at least not easily. And
yeah, and like in this talk, he lists Go as like, he puts Go in the revolutionary category of like simple and engineered. And like maybe it was when it first came out, right? Because it was designed, like it was engineered and it was simple when it came out. But I'm struggling of where to place it now. You know, like because I agree with you. I don't know if it's there anymore. And like I guess I could share a screenshot.
I don't know if it was ever engineered. That's interesting. I guess like engineered from design, sure, but I think like the history of how Go came about and how it like solidified into what it was, I feel like it's definitely an emergent thing. Maybe I'm just not understanding how he uses emergent in this case.
Maybe, yeah. And I'd have to like go through this again as well because it's been a minute since I watched the talk. But like, I definitely feel that Go is like slipping.
It's definitely it was simple, right? It was solidly in simplicity.
There's no doubt that it's
Whether
on the
it's
right side of
engineered
this.
or
Yeah.
whether it's emergent, or maybe it sits on the line between, because a lot of the decisions of Go were made with the goal of building a language that you could build software at scale for. So it was very much like we need, like, what are the problems that people are having when they're trying to build software at scale? Okay, let's solve each of those problems. Because you know what really puts it in emergent for me and not engineered is the fact that generics didn't come until like 13 years into the language, like, or like at least a decade post 1.0, right? Like, generics weren't added till later. There's still not a good story around error handling. We already talked about some of the warts around imports and how you can do an underscore import and just use side effects, right? Like, those aren't decisions that were like engineered. Like, they were not thought through when they got added to the language. Right. They were emergent things that got added. It's like, oh, well, what if you just want to, it's like, okay, we don't want to have junk in your imports. So if you're not importing, you're not using an import, then that shouldn't be allowed. Okay, but what if you don't actually want to use an import for the thing, for like to use a symbol, but you just want it for like its init effects? Okay, let's have an underscore. That will be the throwaway. Oh, we'll just use the underscore elsewhere to mean throwaway. So if you don't want to take a return value, oh, we'll use underscore and we'll throw it away. Like, that feels like a very, like, maybe because it happens so quickly, it feels more engineered than it does emergent. But to me, the way that everything has come together feels emergent. Although I can see from someone who was not and has never been, I don't think, a part of the Go community, I can see why from the outside it feels like a language that is engineered over emergent. But to me, my gut reaction is like, Go is a very emergent language.
Yeah, I think he mentions in the talk, like he even brings up like, I listed Go here for XYZ reasons. So I'd have to play the talk and hear what he said there again. But like, I think I agree with you. Looking at this quadrant, and I sent it to you on a message. I think, yeah, okay. Looking at this quadrant, I can't say I put Go in revolutionary, and like, but I don't also put it in rebellious. I think it is slipping to like accreted. I really do.
I think, if we just use these words, I think that Go, this is interesting. Once again, I think outsiders would see Go as revolutionary, but I think that from someone that was in the Go community from pretty early on, I would see it as rebellious, right? I guess that's the issue here. Like, Go Funked, I see as like a rebellion against other, like, it's a rejection of the idea that, like, we as individuals should get to choose how our code is formatted. I guess you could see that as revolutionary. I see that as like giving a giant middle finger to everybody. So, like, because we're a community of people that is just like, I want my special way of viewing things and my way is correct. And Go basically just said, nah, you're all wrong. We're going to do it this way. We don't care how you feel about it. That feels like a very like rebellious thing at the end of the day. Or like, there's so many things about Go that feel more rebellious than revolutionary. Because in fact, I don't think using the label of revolutionary for Go is a good label. I think that's a bad label, because what did it revolutionize? It didn't introduce a whole bunch of new things. It just took stuff that was there, looked at the status quo, said, fuck that status quo is not what I want, and did something different, which I feel like is the definition of rebellion. Like, I think it is like,
yeah, I think this may be like, right. Because you can, like, I think we're very squarely in agreement that it's definitely on the simple side of the spectrum here. And I don't know where I'd place it on that y-axis of revolutionary rebellious. I don't know if it's fully in one or the other, but it's definitely not like, I don't know, maybe it's closer to the line, right? Maybe it's closer to the line, and it has a little bit of aspects of revolutionary scale and rebellion.
Like, for instance, Go has never had, and because of the way you design things, will never have central registry. Like, basically every language that was invented or got 1.0'd around or after the time of Go has a registry. Rust famously has a registry. I mean, Zig is a little different, but Zig is also kind of a rebellious language, right? So it's like, there's no central place you can go, or there wasn't. Well, there still isn't really a central place you can go to find like all of the Go code, right? That's not true of other languages, but other languages pretend as if that, right? I would call NPM revolutionary, right? Where that was one of the big ones that was like, here's where all the stuff's going to be. And we're going to have like this tool that helps you download all the things, because Node came about around the same time that Go was coming about, right? And before that, the older languages, they either had frameworks or other ways of doing things. You know, Ruby is obviously the OG for having a lot of this stuff, or really Perl, PHP and Perl and all of that. But like NPM kind of stands out there as like a big, like,
he lists Node as I was such an idiot, and I was like scrolling through the YouTube video to see the slides, and then there's a speaker deck link right below, so I could hit the slides. He lists. So here, let me give you what he lists. So constructed, he lists constructed as like operating systems, basically is what he says. He's like, operating systems, compilers, and databases. Those are constructed systems because they have to have a lot of complexity, and they're engineered to like handle that complexity. That's the whole point, right? Like storing, and I think we can agree on that. Like operating systems, compilers, databases, that's the whole point of them. They are always going to be complex because they're engineered to be complex and handle that complexity. Got it. The rebellious systems. So now we're, jumping to the other diagonally across the axes here. He lists Unix, C, RISC, Rails, PDF, Node, NoSQL, Talos, Ubuntu, Rocky, like these Linux distros. As in like they're rebellious because they're challenging. Does it have to be as complicated? They're challenging the complexity, right? So like I think
I don't know how you don't put Go in that quadrant.
Yeah. Maybe. I think I can see that. I'm gonna yell at Bryan. And then accreted systems are like, you're not, that's not a system you would design from first principles. You like accrete that over time. And he says like, UEFI, BMC, IPMI, like these things are accreted over time.
List himself as accreted.
Because you would never.
I'm just kidding.
Yeah. And then the revolutionary stuff is like, when you throw out sort of all of when you design from first principles and you keep it simple but also engineered, you have this, the revolutionary side. And he lists like TCP/IP here, Python, NFS, Plan 9. There's many, but I'm reading like the ones that maybe all of us are more familiar with. HTTP is in here, Java's in here, SQLite's in here, LLVM, the iPhone, ZFS, Go, TypeScript, Docker, Rust, Oxide. Right.
Like
there's some other things.
I agree with most of those except for Go. Right.
Yeah, I think a case, and I need to hear, because I know he said something about Go being in here because people know that like Bryan's a big Rust guy and blah, blah, blah. So like, why is Go here? I think he actually said something in the talk about it that I want to hear, but I think I agree. I don't know if I see Go as a truly revolutionary.
I see Rust as revolutionary. I think it is squarely like it is simple and it is definitely engineered. But I think that's one of the things that makes Go and Rust so different, is that Go is not engineered. And I feel like that is so much more obvious now in hindsight, now that we've definitely slipped into accreted land. Is that like, Go was not, there's not like a master, there's not like a high level thought of like, this is how Go should be. Go is just like, we need to make building large software simple. And then there was a whole bunch of stuff that got added to that with some mistakes, hence the warts we have. But for the most part, until we hit modules, we remained simple, right? It was simple to understand. And I think too, like, there are so many unanswered questions in early days of Go. Like, how do you deal with dependencies? I don't know. Go figure it out yourself, right? That's not an engineered system. That's not an engineered solution, right? Like Rust went and there's like, oh, well, we have crates, right? We have crates and we designed this thing called cargo. And the way you effectively use Rust is that you use this tool that we've built that allows you to do all of your dependency things that you obviously need to do for a programming language, right? And since he didn't list cargo there, I assume he's probably putting Rust and cargo as like a shared thing. But even without cargo, Rust is still very like designed, like an engineered thing at the end of the day. Its whole type system, the way it does like borrowed checking and all of that, like all of that is like very engineered. Whereas like Go, it's so hard to say it revolutionized things because it didn't come up with new ideas. That was a criticism of it for so long. Like, what's new about Go? Like nothing. The thing that makes Go is that it looked at what the industry was doing and said, we think you're doing these things that we're doing wrong, so we're going to do them differently. We're going to rebel against what everybody else is doing.
Like I look at most of these other things and like I see how like, the iPhone is revolutionary. I see how like, S3 revolutionary because they're like, you know what, that whole file system crap?
Yeah.
Nah, here's just think of it like this: API calls, TypeScript. TypeScript is in an interesting spot, but definitely because they took JavaScript and they're like, hey, like it doesn't need to be this way, but also we're going to keep it compatible. So like it does maintain a level of engineered, right?
I think it was kind of the first language that added. I guess PHP sort of did this maybe a little earlier, but like it was one of like the big languages. Like, oh, we're going to add types to this language now and have a whole type system and figure that all out. Very engineered thing.
Yeah, I don't know. I really enjoyed this talk when I first watched it. I wish I went there. I was supposed to go there, but then I didn't go there. But like, I wish I went there to see it in person or whatever. Because Bryan's talks are always pretty fun to.
Now we want to listen to this. I'm gonna go watch this talk because I'm like super.
Yeah, you should. Yeah, we could probably talk about it more because there's a lot of good content here that we could probably actually even do an episode on or just chat more about. Because I like thinking about these things in this way because I feel like there's a slip of Go, and I feel like it moving out of one of these. It's definitely moving in this quadrant, like in this graph. It's definitely moving, and I don't know exactly where it started. I think I agree with you that it's in that like simple, possibly on more of the rebellious side, but it's definitely I think going into the Accreted side.
I think if I look at this, when I look at this quadrant, right, these quadrants, and I think about if you believe that Go is a system that is in the revolutionary spot, and then you're like, how do we fix some of these fundamental problems? I think you would fix it by trying to do engineering, which is clearly what tried to happen here, right? Like clearly, like someone tried to sit down and come up with a design that would solve the problem space in one fell swoop. And since this is not a engineered system, since it is an emergent system, that just shoved it all the way over into the Accreted land. Because when you do try to have those, like when you try to treat a system that I have to watch the talk still, but in my mind, when I hear these words, and they're probably close to what Bryan thinks about these words, is like when I hear an emergent system, the problem with emergent systems is that they don't have an underlying design philosophy that's going to run through them. So you can't apply universal rules in the same way, right? The easiest example is, since we're talking about what?
Sorry, I don't mean to interrupt you, but I really wanted to find out while on the call, like what he said. And he says, here, I'll verbatim say it. He says, Go is, I put it in the revolutionary category, but I believe it's on the cusp. I think it's kind of right on the cusp of revolutionary and rebellion.
Okay.
I'm trying not to throw up in my mouth when I write Go on the slide. Is what he says afterwards.
Oh god, we need to have Bryan on so we can have some conversations about it.
Yeah, I think it's time to get Bryan on. I'll talk to him in my next our next one-on-one and chat with him
because at least putting it on the line, I'm like, okay, that makes more sense. I would just squarely put it.
Yeah. Okay, that because when you look at the slide, it's listed in the revolutionary slide, but even when he's saying it, he's like, it's on the line here.
Yeah.
So clearly he understands it too. Okay. Yeah. Cool. So we are all on the same page.
I think that's the thing of like when you try and take an emergent system and apply engineering to it, I don't know if you can just move it up. I think what happens is it does just slide over, because like engineering principles require like a foundation that doesn't exist really. Maybe I don't really know. But I think it's like I think the problem is that like if you wanted to apply engineering, it would be much, much, much harder because you have to deal with the constraints of the emergent system, which means you have to think about engineering at an entirely different level, which I don't think is what happened, because I do think people probably put it in that top right quadrant instead of the bottom right quadrant.
Yep.
So,
agreed. No, I think there's more to discuss here, but I know it's break. We have more time to talk in the future about a lot of this stuff, and it gives you time to watch talk too.
Maybe we'll do an episode. Maybe next week's episode we can talk about this. This is an interesting topic, so I want to talk about it.
It is an interesting topic, and there's a lot of cool technologies here, and it really is fun to see how these things are like, how they start their life in one quadrant and kind of move to other places or whatever. And there's lots to be talked about here, I think.
Well, listener / viewer, what do you think? How do you like that conversation? What do you think about where Go lives in these quadrants? Let us know on social media, in Gopher Slack, Changelog Zulip, or wherever you find your lovely Break or Fallthrough host or co-host. This episode of Break featured Chris Brando and Matthew Sanabria. Break is a Fallthrough media production and is produced by Chris Brando, and our beats are by Breakmaster Cylinder. Completed.
Done.